Okay, today I'm going to be showing you how to make your own cloud chamber to detect subatomic radiation particles. So how it works is you have rubbing alcohol vapor in here, and then I'm going to set it on dry ice and it'll make the bottom layer become supersaturated. When the supersaturated alcohol vapor gets hit by a radioactive particle, you'll see a streak go across it. So even though you're not seeing the particle itself, you're seeing the path that the particle took. And the reason it creates a path is because the particle comes through at very high speeds and it knocks electrons off of the rubbing alcohol, and it creates a nucleation site for the supersaturated vapor to condense into liquid. And so basically it makes a little condensation cloud that you can see. And this is really easy to make. So basically you can make your own particle detector for just a few dollars. Let me show you how you make it. And all you need to do this is some rubbing alcohol, aluminum foil, some black paper, a sponge, and a cup. So to do this, what you do is you just get your sponge, put it in your cup, you soak it in your isopropyl alcohol, and I'm using 99% isopropyl alcohol. Usually the kind that you get in the store is around 70%, but it works better the higher percentage you have. So this is almost pure alcohol. And then all you do is tape your black paper on the bottom. So all this black paper is for is so that you can see the radiation better. Then you just need some sticky tack stuff that you can put around the edge of the cup. And this will just act as the seal. And then what we're going to do is we're going to set this on dry ice. So dry ice is probably the only thing that you may have a hard time getting, but usually a lot of grocery stores have it. Okay, then you just stick your cup over it and get a good seal. Now we just need to put it on dry ice. So you set it on there, and then I'm going to shine a flashlight in there and get a different angle, and you'll be able to see what I mean. So there they go. Do you see those little paths going through there? There goes one bottom left corner. So cool. Basically what we're seeing here is background radiation. So the particles that we're seeing, it can be alpha particles, beta particles, or gamma particles. So gamma particles are photons, which are light, and beta particles are electrons or positrons, and then alpha particles are groups of 2 protons and 2 neutrons. You can also tell what type of particle is hitting the gas chamber. For example, alpha particles make a straight, thick line, and beta particles kind of make a curved, wispy line. Most of these particles here are from the natural radon that's in the air, and also we receive cosmic background radiation all the time also. On average, we're being hit with around 15,000 of these particles per second every day of our entire life. If you think about that, it's quite surprising that we don't have more cancer than we do, because all of these are ionizing radiation. So if these particles happen to hit one of your DNA molecules, it has the potential to cause cancer. What's even more amazing is how fast these particles are actually moving. So the alpha particles, they're moving at around 15 kilometers per second, around 5% the speed of light. And the beta particles even faster. They're moving at around 40% the speed of light. So the beta particles that I'm seeing can also come from cosmic rays. Another source can be my own body here. We do have potassium-40 in us, and potassium-40 undergoes beta decay, so it shoots off beta particles, and that's probably some of the radiation that I'm seeing in the cup. So I thought this one was really cool. So what you see here is 2 particle paths crossing, and you'll see the one that comes later, there's a gap where it crosses the first particle path. That's because where the alcohol already condensed, it couldn't condense anymore because the first path already condensed that alcohol. And so when the second particle flew past it, then it couldn't condense near that area, so it looks like a gap in the path. But thanks for watching again, everybody. I hope you liked this video. If you're not my subscriber yet, remember to hit the subscribe button and hit the bell to be notified when my latest video comes out. And you can ask me any questions you have in the comment section and I'll try to get to them, and I'll see you next time.